Welcome to The Explainer. Today, we're taking a virtual expedition to a place that is, well, it's both one of the most stunningly beautiful and one of the most extremely dangerous spots on the entire planet. I'm talking about Mexico's giant Crystal Cave. So here's our plan. First, we'll get into the accidental discovery. It's a great story. Then, I'll be your guide through its unbelievably lethal environment. And finally, we'll dive into the half-million-year-old science that created this masterpiece.
But before we go any further, just take a look at this. It looks like another planet. Now, think about this question. How long do you think you, an unprotected person, could last in this room? The answer is shockingly, terrifyingly short. Keep that number in your head as we explore.
Okay, let's get into it. Our story doesn't start with scientists on some grand expedition. Nope, it begins with miners working about 300 meters, that's nearly 1,000 feet below the surface, in Naica, Mexico. So if you look at this timeline, the story of the cave really starts millions of years ago with volcanic activity. But the real magic, the part we care about, started about 500,000 years ago. That's when the conditions became just perfect for these crystals to grow. And then you fast forward all the way to the year 2000. Miners, who were just looking for lead and zinc and silver, pumped all the water out of this cavern, and they stumbled upon this absolutely incredible hidden world. And what they found? Well, it was a chamber just filled with the largest, most perfect crystals ever seen on Earth. I mean, some of these selenite beams are as long as a telephone pole and weigh more than a humpback whale. It's like finding Superman's Fortress of Solitude, but real. All right, now, before our virtual tour enters the main chamber, we have to gear up. And I mean really gear up. So let me put on my tour guide hat for a second. My first and most important job is to tell you that this beautiful place is incredibly hostile to human life. You can't just, walk in here. This quote just perfectly nails the core danger. The insides of your lungs would actually be the coolest surface around. Think about that. It's a truly chilling thought, and it highlights that the real threat isn't just the heat. It's what the superhumid air does to your body from the inside out. So the first thing that hits you is this blistering, oppressive heat. The temperature is consistently hanging around 58 degrees Celsius. That's 136 degrees Fahrenheit. To put that in perspective, that is hotter than the hottest day ever recorded in Death Valley. And then there's the humidity. It's suffocating. It hovers right near 100%. In an environment like that, your sweat can't evaporate, which means your body has absolutely no way of cooling itself down. None. So you take that heat, you add that humidity, and what do you get? You get a survival time of about 10 minutes. 10 minutes. That's all you've got before you'd collapse from extreme heat stress. What a brutal place. But the most immediate and honestly terrifying threat is something straight out of a nightmare: internal drowning. The air is so hot and so heavy with water vapor that when you inhale, the inside of your lungs is the coldest surface that air touches. So the vapor instantly condenses back into liquid water, filling your lungs. You would literally drown in the air you're breathing. To even think about surviving in there, scientists need gear that looks like it's from another planet. These are custom-made suits with a circulating coolant system just to fight the heat, plus a specialized breathing apparatus to give them safe, dry air. But even with all this incredible tech, they can only stay inside for about half an hour. That's it. So how on earth does such a deadly place create something so unbelievably beautiful? Well, let's step into the science classroom for a minute and find out. The recipe for these giant crystals required this perfect storm of chemistry, geology, and just an immense amount of time. The whole process, laid out right here, is basically a recipe that took 500,000 years to cook. It started with magma deep below, heating up groundwater and just packing it with minerals. This super rich water then flooded the cave. But here's the crucial step. That water stabilized at a very, very specific temperature, and then it just sat there, completely undisturbed for century after century, letting the crystals form. And the real key, the secret ingredient, is this specific temperature: 58 degrees Celsius. That's the magic number. You see, above that temperature, a mineral called anhydrite is stable. But at or just below 58 degrees, that anhydrite starts to dissolve and slowly reform into these massive selenite crystals we see today. So to really understand why these crystals got so huge, we can just compare it to another cave nearby, the Cave of Swords. That one's closer to the surface, so it cooled down way faster. A rapid process like that creates lots of small crystals. But in the giant crystal cave, the temperature just hovered right at that magical 58-degree sweet spot for 500,000 years. That allowed just a few crystals to grow slowly, steadily, and become absolutely enormous. But here's the twist. The very thing that let us see this wonder, pumping the water out, is now the cause of a huge debate, because that incredible crystal-forming environment, it's gone now. So you have to ask, without that mineral-rich water that both created them and physically supported them for thousands of years, what's going to happen to these giant formations? The very air we breathe is now a potential threat to them. And this puts scientists and authorities in a really tough spot. I mean, what do you do? Do you reflood the cave? That would preserve the crystals, maybe even let them start growing again, but it would hide them from us forever. Or do you keep it drained so we can study it, knowing that the exposure to air might slowly cause them to crumble and decay? And that brings us right to the heart of the paradox, doesn't it? Our very access to this natural wonder might be the thing that ultimately destroys it. Trying to balance our thirst for knowledge with the desperate need for conservation, that's the great challenge here. The moment we first laid eyes on this place was the moment its 500,000-year-old life cycle was stopped in its tracks. And that leaves us with one final big question to think about. What is the true purpose of a place like this? Should it be a museum, something for us to observe and study? Or is it a living, breathing laboratory for the Earth, a geological process that we should just leave alone to do its work, even if that means we can never see it again?